Greetings from Calgary. When working on Gadgeteer projects, sometimes you can't find a suitable existing Gadgeteer module. But don't worry, as breadboarding with Gadgeteer is very simple, and if someone has breadboarded what you need, then it can be very easy to share. This project is an example of how easy it is to share breadboarded solutions with Gadgeteer. So simple, in fact, that people using this don't need to understand the details of the hardware or even the low-level code. To them, it appears to be just another Gadgeteer module. All you have to do is follow some easy instructions to wire it up, and it can be shared with more than just Gadgeteer projects. With some small changes to the code, you can use these with a Raspberry Pi running Windows IoT, for example, using a Fez Cream, or given the source code is written in C#, you can use the code with .NET Microframework or .NET. So this is a really powerful way to share code across a broad and expanding user community. In this project, I wanted to experiment with AMS's AS3935 Franklin lightning sensor, as it is an unusual and interesting chip that detects the electrical emissions from lightning and then provides for an estimation of the energy and distance from 40 kilometers away down to 1 kilometer, while rejecting disturbances from man-made signals such as motors and microwave ovens. In short, it is just a very cool sensor that I wanted to try. Now, this chip can use a serial peripheral interface, also known as SPI, or an I2C interface. Now, I'll skip details of how those interfaces work, as there are YouTube videos on those. But for now, it is enough to know that these interfaces are examples of how chips can communicate with each other in a device. So I purchased a MikroElectronika Thunder Click, which by default uses an SPI interface, and an Embedded Adventures Mod 1016 lightning sensor, which by default uses an I2C interface. You can change which interface these devices use by changing some jumper settings on the boards, but I wanted some different boards to test, so I got both. Note, I will include links to everything below, including the source code. I previously released a video on how to build module drivers with Gadgeteer, so I'll just give an overview of my AS3935 driver, starting with the SBI driver for the MikroElectronika Thunder Click board. The general idea behind the AS3935 Lightning Detector chip is once it is running, is that it watches for a 500 kHz wave patterns and analyzes them to determine if the source is lightning, which then results in a lightning interrupt being raised, or if it's some other non-lightning source, it raises a disturbance or noise interrupt. As mentioned, it can detect lightning up to 40 kilometers away and even gives you some idea as to the energy in the lightning. So it has lots of settings that you can further tune or configure for the chip. In SPI and I2C, the idea is to read or write to different registries. So in the code, you tend to have registry and bitmap constants. So the code is very similar for SPI and I2C, and the only significant difference is in the actual SPI and I2C level code. So here, we're seeing there's tons of bitmaps so that we can manipulate the registries in the chip. And there's also a number of settings. Like I said, there's a lot of customization, that we can do. And so here's like all the registry settings that we can manipulate bits within those registries. We can either read data, or we can write data, or execute a command with them. This item here is something to be noticed of. The chips are, they're tuned for antennas and stuff, and so like the Embedded Adventure, for example, when I ordered the board, it came with a number attached to it, and that was their recommended setting for the tuner capacity. You can run separate tests for this, and so I've got a space here for that. And then like there's AFE gain boost for the antenna, which is it inside or outside, and the power mode that it's on. You can mask disturbers so they don't raise events. You can set the noise floor level and spike rejection level. So it's a very configurable chip for determining lightning and stuff. So when we connect up, this is the SPI. You know, we have to reserve a number of pins and stuff for SPI to use for communication. And so it's very simple to do this. And, you know, settings, again, more settings, power down, noise level, watchdog levels, that's another configuration setting. A number of minimum number of lightning required for before it raises a lightning interrupt, spike levels and stuff, mass disturbers, as I mentioned. I added some routines in here to dump the registry so I could use it for debugging. Make sure my registry settings were right. Again, we can set, there's a deal here to clear statistics to sort of undo some of the learning that it's done before on what lightning is, and such. And so, you know, when you initialize the chip, you want to do a reset, put it back into a default configuration, and then calibrate, call the internal calibration routines. And then this is just the stuff for the interrupts. Now, on a lightning interrupt, what you want to do is that you actually kind of want to, if it raises a lightning interrupt, you want to kind of pause for you know, a small period of time, 2 milliseconds kind of thing, and then you can go read some registries, and that's when it's calculating up the distance and the energy within the lightning. And so that's something to be mindful of, that you have to do things a little bit differently when there's the lightning calls. And then down here are the routines for reading and writing and such with SPI. How we do our resets at you know, the energy, distance, and then there's a class that we have for passing the arguments through on with the lightning event. Now, you know, of course, if you watch my other video, you saw that, you know, yes, we have to modify the hardware XML file so that, you know, we give it the, you know, board height and such. You'll see in a second how I kind of did the board height. It'll make sense and stuff. Some naming and some, you know, where everything is and what pins are reserved and such. So let's take a look at this. I mean, this is a little different. So what I did was I took GHI makes a Gadgeteer breadboard, breadboard X1, and so what I do is I mount the Thunder Click on that board, and then this is how it's wired up. And so when I build this thing, and we'll see when I get to the demo application, this is what shows up as the Gadgeteer module, and then I'll show you how easy it is to use. So that's how I build the visual representation of this module. And then I always like to include a test app in my code and such for people to look at. It shows them, you know, basically, you know, we have all these different settings, but, you know, principally we're interested in these interrupts that the chip raises, whether it's noise or disturbance or lightning, and then with the lightning we can say what the distance and the energy is. So that is that chip. Let's have a look at the I2C version of this. And again, you'll see that it's very similar. It's pretty much identical code. The only place that it really changes is when we get down to the end. There's some different things that we can do with the I2C interface. There's some error tracking and stuff that we can put in. But I mean, pretty much the code is identical, so it makes it really easy to write both versions of this. We'll just pop down here a little further. You know, shift counter, how we can read the raw registries and stuff like that. There's some error detection with the I2C that we can use and such. So I mean, it is identical pretty much. Again, the XML file looks very similar. We're going to do the same sort of thing with the mounting of the embedded adventure lightning sensor. We're going to put it on top of the breadboard, and then again we can show how it's wired up. I guess the other thing I should point out is that how it's wired up is also in the code. So if you put your mouse over, and we'll see this later, you'll see this wiring schematic come up here that allows you to you know, sort of read the instructions, or you can visually see the instructions as well. So I think that we'll switch over now, and what we'll do is we'll go into the demo project. And again, as you can kind of see, when we so I've built both of these Gadgeteer modules. There's an installer. I've run those, and so now that both of these are now added down here to where we have the MikroElectronika group, that there's a lightning detector in here, and same with the embedded adventures. So I mean, for example, if I was to grab this, I could drag this over and it shows up as a Gadgeteer module. And if I was to click on this, it would show me that, oh yeah, I can plug that into the socket 9 and stuff. So we'll just delete that. So, I mean, as a coder now, you're not worried about the hardware details. So if we go in and look at the code for this, I've got this again where I'm just capturing the events and changing some LED lights and such. So you can see, as somebody who is now using this lightning detector as a Gadgeteer module, everything is there for them that makes sense without having to know the low-level code. So if I come in here, we do this, I can, so there's, I have you can call the calibration clear statistics or display the registries, and, so you have all the configuration settings available to you. So it's all there without you having to know how an I2C interface works. I almost called it an I2C, or an SPI interface. Now, if you put your mouse over this, I'm gonna have to give it a second. It will display. Sorry, there it is. There, it will display the wiring for this as well in the documentation that comes up with this. Same with the SPI. So it makes it very easy to use an AS3935 lightning detector with Gadgeteer. Now, like I said, anybody that wants to install this module, all this goes up on GitHub. I'm gonna try and make it so that if you don't want to see the code or whatever, that you can download just the installer that will add these to your Gadgeteer toolbox, and then that, like I said, it makes it really easy to share code. So now let's fire this up and see how this works. One thing I should mention is that a lot of people, when I was kind of working on this, I saw they had a lot of problems with the chip apparently not working. Now, the AS3935 is a very sensitive chip, and you need to make sure you're not working beside your laptop computer LCD screen or whatever, as these tend to be electroradiation swamps, and it can interfere with the operation of the lightning detector. So I try to power off as much stuff in my office and try and minimize other things that might impact how well my demo works. So anyways, let's fire this up and see how it goes. Now, one of the things I want to show on the demo board that I put together is that we can see that on this guy here, we've got him wired up exactly on an X1 Gadgeteer X1 breadboard from GHI Electronics. But this guy here, this is the Embedded Adventures chip, but I've soldered a header onto him, and then I have taken a Gadgeteer extender module and I've soldered a header onto that, and so I've wired it up that way. What I really want to show or say is that it doesn't have to be on a breadboard for you to use this. I mean, all that matters is that the pins are wired up to the pins in the code. If you went into the code and changed which pins were hooked up, that's still fine, as long, of course, as those pins are going to work with the main board that you've got, or the socket you're using, or whatever. Now, one of the things I should point out here is that when I was testing this initially, I mean, I'd put this together, and then I would hope for a lightning storm to roll through earlier this year, and I was seriously thinking about changing the name of these chips from Lightning Detector to Lightning Defender, because as soon as I had them hooked up, we didn't get any more lightning storms here, and so they do a great job at defending against lightning as well. And so one of the things that I got that made a huge difference for me being able to test and such with this, and was I got the SDK kit from AMS, and it includes this emulator. And so this emulator has I can create a disturbance, noise, far strike, medium strike, or close strike. And the other item that it comes with that I found, which was very handy, is it comes with a little reference board. Now this is kind of how I found out that in my office I have a minimum of 3 computers and big LCD screens and stuff like that running. There's LED lighting and fans and stuff that are fairly close to me, and so what ends up happening is that I get a lot of electromagnetic disturbances here in my office, and so I was kind of pulling my hair out trying to figure out why this wasn't working or whatever. And then when I tried their reference board, it didn't work either, and it was like, oh, okay, so there's got to be something going on. And I did a little kind of poking around, and people mentioned that they'd had experience that these chips were fairly sensitive. And so this board here, being able to have a reference was really good for me, because it helped me to determine that, it wasn't my code or my wiring up of the device. It was I had some devices that were running in here that were just creaming the chips with false signals and stuff, or blocking or interfering with their operation. So it wasn't so good. Now it's November currently in Calgary, so I'm way past lightning season here, but being able to have this emulator board it's really good, because I can test it anytime and stuff. So that's really good. So let's fire this up and see what happens. Now, as you can see, I do have some things kind of going on around here. I know there's some electrical motors and stuff running. So let's see if we can create a disturbance that shows up here. So yeah, they both registered up with the disturbance. We'll try noise. Now the noise tends to start off as a disturbance, but then it kind of goes into being noise. And so we'll see. Yeah, both of my guys picked it up, and there's their little emulator. Their emulator hasn't picked it up. Now, typically you got to be about a foot or so away from the receivers with this emulator for it to work. So we'll try a far strike and see if anything. So like I said, you can see that their board hasn't picked it up, so I'm not feeling so bad. Like I said, there's always lots of stuff running in my office or around my office. So we'll try that. Okay, we picked up both of my chips were able to detect that lightning strike. Same with that lightning strike. And we'll try a close. So one picked it up as a disturbance. We'll try that again. And okay, so the other one picked it up. So one of the things I have noticed is that these chips don't necessarily get every lightning strike. But in the lightning storms like that we get around here, there are tons of tons of lightning. We can get some pretty, they might be small, but they're pretty intense little storms, and so being able to track them with this would be really handy. So, yeah, pick that one up. Maybe I need to be kind of pointed a little better. Yeah, so this is it, and playing with this emulator, I was also able to determine just kind of how I kind of had to do. So to get the reference guy to go, we have to kind of move our emulator over a little bit towards him, whereas if I move it back towards my guys, they both pick it up. The other thing that I've noticed is that tuning of the boards is kind of important. So I built a tuner with Gadgeteer that allows me to go through and automate the tuning of these boards. Now I've noticed that I think that I've run it with the SPI board and came up with its settings, whereas with the Embedded Adventures board, I think that my tuning was maybe a little better than theirs. So I'm using their number currently, but it's not too bad. And if I was to I'm also trying to shoot around the my camera stand and stuff here too with this, and so we can see it works pretty good. I'm picking up lightning strikes and such with it. So I hope that all of this, that you find this helpful and useful, and that for you guys that are using Gadgeteer, it's now, literally just a Gadgeteer module that you need to plug in to have a lightning detector module now for your say your weather stations or whatever. I was kind of curious about this, for detecting lightning in terms of where there's potentials for forest fires and stuff, that we know if there's anything that comes by where we have a place in British Columbia where they get a lot of forest fires. We're very interested in lightning and how close it is to where we are, so that we know if what the chances are of a fire starting within our area, so that the fire crews can be dispatched to put out a small fire versus a large one, which is certainly a more effective use of utilities and resources. For example, this summer we were able to spot a couple small fires around Kootenay Lake, and they were able to send one helicopter with a bucket and put the forest fire out then, and rather than it becoming a major forest fire requiring tons of resources. So again, I hope you found this enjoyable. I will be posting some more videos like this where I've taken breakout boards and converted them into similar types of Gadgeteer modules, and hopefully you find them useful. So happy Gadgeteering!